And we're live. So, we're going to kick off this Code Monkey Talks series of, I don't know, brown bags talk, so that we talk about different... Oh, did we lose Prasanna? Hopefully he jumps back in. Yeah, so we're going to talk today about... so I'm Brian Jackson. I am a technologist. I like cool new stuff, and that's what we like to talk about here. I'm with Brian Demers, and hopefully soon Prasanna Gautam is going to rejoin us because we're going to talk about some stuff that is interesting to him. So give us a sec and see if he comes back in. Ping him on chat.
There he is.
Sorry, guys.
No, that's okay.
Got bounced out by...
No. So I was just kind of doing a quick intro. That we're technologists. We like we like playing with cool stuff. And today you were gonna talk about some stuff. I would say it's in the platform as a service space, but it's also somewhere in between there too. So I will kind of turn it over to you, Prasanna, to kind of guide us with the technology stack that you kind of want to intro to us today.
Yeah, so today I'm going to be talking about Mesos, which is a project created by Twitter based on another project by Google. The core idea is it's sort of the holy grail of distributed systems, right? The clear, the mandate that people wanted to build was a data center or a cluster of machines as a single computer. And a lot of when you start going up to many different systems like Google or Twitter, where you have thousands and thousands of nodes, we can't really keep making these little snowflake services. Your Gmail team just runs everything in 5 machines or 500 machines, that sort of stuff. And now you add to something like they are always failing all the time. You always need to be backing them up and those sorts of things. So what they did was they built out this system originally called Borg to allocate resources. So your standard, go run my job, here's a master, and then this will track what the status of the job is, and then when you're done, come back to me or store something in a file store. So that's the first generation of this. The second generation of that is, what if you could have multiple kind of workloads, right? You have a long-running task, say I'm doing Hadoop-type work, or I'm running a web service, I'm running very short-lived jobs, which is just like a clock, cron type work on the same cluster, right? And they can think of it as like you have a kernel that's spread across your whole cluster, and then you're just stealing cycles from all of these places. So what I'm going to show today is this company, Mesosphere, that spun out to provide service for Mesos. So I spun up an instance on our EC2, six boxes using their Elastic Mesos client, and I deployed a few services. And I wanted to talk a little bit more, hear what Brian, so any questions you have, concerns, those kinds of stuff on Mesos too.
Cool. That sounds really exciting. I'm excited to kind of see it in action. We've been talking offline about various different technologies in this space, and I'm very interested to see where Mesos kind of fits in. And I know you and I have mentioned running something like Flynn on top of Mesos, and I'd love to kind of hear your thoughts in that space too.
One of the interesting things before, so I was at MesosCon 2 weeks ago, and that was awesome. Like did some crazy stuff. But I was at the hackathon with a bunch of people, including for a lot of coordinators there. The interesting thing that they did this with this new version, and that sort of puts this is my operating theory. If any of the Flynn committers actually like listen to this, then it'll probably be validated. Is that before the current version, 0.20, there was no direct-to-go integration into Mesos, so you still had to like write your own scheduling algorithm. But from now, like now that they have that, I actually see that path being much clearer. To use something like Flynn as just one of the frameworks, right, on top of this computing infrastructure.
Very cool. All right. Well, so do you want to kind of dive into what you want to show us?
Yeah. So I think I'll just share screen if I can figure it out. How do I actually screen share? Oh.
Yeah. Yeah, over on the left side, right? There's a screen share button.
So might have to make a new window or something like that.
Okay.
Didn't really want to get into an infinite loop here.
Oh, I see.
So okay. So what I'm do you see this?
I see black. I see black right now. Oh no, there we go. I see it.
So this is something I deployed yesterday, which is basically just what's called. So let me actually go from slightly back. So this is. So this is the Mesos console.
Okay.
Right, there are some tasks that are being run right now on Mesos. That is like you see some every minute I'm running sort of a hello world kind of task, which I'll get to in a little bit. You can actually see that I have a total 19 gigs of memory in the cluster. I'm using 4.5s. They have a problem, I think. No, okay. So I have total 6 CPUs. I'm using 4.5 CPUs. 1.5 are idle. And you can actually get that at any point in the system. What Marathon is doing is I'm actually running. So this is designed to be basically, if you think of Mesos as your kernel, Marathon is designed to be the initd, right? Init process, which is creating all of your services that will be long running and will keep like monitoring them and stuff like that. So what I have on one side, so that you can actually, if you want to deploy a new app, it's really just you tell Marathon, go to this URL, download this, and run a script, right? Okay. So I'll show you the very simple Play app that that they had over there, and then I'll go into the other one which might be slightly interesting to Brian on the running Jenkins, Jenkins master on Mesos directly, and potentially running slaves. I haven't gotten that to work as well. So basically, like if you can see this, all I had to really supply was say, I want 2 instances. I'm going to give them 1 gig of memory, 500 megabytes of space, and it randomly generated a port, right? So now I want to scale up, and you've already seen the cluster. I think I have 3 slave nodes, and I just gave it a number 3, and it'll be shortly spinning up a new instance that's running a very simple Play framework application.
You might want to go slower, just because I think the frame rate is low, and like I didn't actually see the scale, whatever the dialogue was for you to say 3.
Yeah.
In.
Yeah, there's like some crazy slowdown that's happening.
Yeah.
On my side too. But
I got the idea.
There's also an API, so you can actually say, I mean, it's all running on EC2 too.
Yep.
So, and Mesosphere makes it extremely easy. I would actually say the Google Cloud one, is much easier, because they probably wrote it later. To just spin up, and it's cheaper. I wouldn't really call it cheaper actually, because you're getting less nodes for the money. So, but it's like what, 56 cents an hour for 4 nodes of just running Mesos, right, for development. So if I refresh now, should have 3 nodes unless there's some other stuff happening. But they're running on. I can give them separate port names, individual port names, which I actually do. I think I do with Jenkins Master. I'll just go back to the Mesos console. I should see them being populated as tasks. So there's a little bit of noise here at the moment, because I'll be getting into the Kronos side of things in a little bit.
Yep.
Damn, this is actually very slow. Is your scroll actually tied to the Google Hangouts?
It might be, or it's just the CPU usage of streaming in HD is messing it up. I wonder, you know what I'm going to try to do? I'm going to try to adjust the bandwidth and see if that changes your, I don't know or you can change your bandwidth, which is, the 4 bar.
You can try to shrink your window too if you're only sharing one window and not your whole desktop. And that may send less bits over, or they may just scale better.
Right. Yeah, I'm just going to decrease the size. Am I actually sharing the whole window?
It's the whole window, not the whole screen. It looks like.
Okay, I just decreased the size a little bit.
Yeah, and we can still see that. We can see that you shrunk it.
Right. So okay, this scrolls so much better. So you can actually see there are some other tasks going on.
Yep.
It may have. So the way actually Mesos works is you have the concept of offers. So there might be something that's happening where I requested for, because I only have 3 slaves, as you can see here.
Yep.
One of them is probably being used by the other process. So that might be one of the reasons why I'm not seeing a third one being spun up. There are ways to look at the logs, but I wouldn't really go and look at that.
But it's like if you have 3, if you have that space available, or you have those resources available.
Yeah, and there's the way it ends up working out is there's an offer model where it's you say I want compute, and the system actually offers you something, and then you get to reject that. So you can write what that allows you to do is, instead of tying your scheduling into your application itself, you get to have individual schedulers for your task, right? So Marathon is not really going to like do ongoing, every day, every 5-second trigger kind of tasks, right? For that, you would run something like Chronos, which is basically like a cron job.
Yep.
You want to run, so this is what I have. Every 1 minute, run something with which is just hostname. Just keep running hostname.
Yep.
And then, and that is actually a parent of, so that's called foo, and the other one is echo foobar runs too, right? So
yep.
A lot of our ongoing work ends up being, and it actually tracks. What's great is when it ran, what is your percentile, how long something has been taking, which is like you don't really get that with your standard cron jobs. Like half the time I can't even tell like if it even ran.
Right. Is one running now? Is it do I have like 3 overlapping because it took so long?
Yep.
Yeah.
And you can actually look at the graphs, and for you it just ends up being a very straightforward, I want thing to be done, find me compute that goes and does the thing, right? If all I'm doing is every 5 seconds going to Twitter and pulling the current timeline, right? It just makes those things extremely trivial, right? And that might trigger 5 other things.
Right. Because I can see how you could program that, you have curl or wget pulling stuff that then feeds into, an awk or a sed or something that like if you're really going Unix scripting.
Right. But this is really like for that as essentially a service, right? I remember the Yahoo Pipes sort of stuff, and
yeah.
I really miss it, right? There's nothing like Yahoo Pipes still after so many years. On the other side, I also ran, this is just a POC thing, some folks at eBay had built Jenkins Master. I've run Mesos as a slave before. And we're intending to do that for a lot of stuff internally, but this one is like, what if I actually ran the master inside Mesos and have that trigger so you have failover and all that sort of stuff. So this one isn't quite really working. It's still looking for some executors, but
yep.
Pretty much the idea, the same sort of concept. I gave Marathon a little script, and it went out, it found the files, and then it runs all of this. And but build systems are one of those examples where you don't need them all the time.
Right.
You use them and then you throw them away because unless you're building things for everything all the time, they are mostly going to be sitting idle, right?
Right. So let me kind of reiterate what I've heard so far, right? Is that Mesos is kind of this base infrastructure that's equivalent to a distributed OS kernel. You've got a Marathon sitting on top of it, so that like here are the jobs I want to start up, and you're kind of in charge. Yeah. Like the analogy you made was like INET,
and it's and they've made it very easy to write your own scheduler and executors, so we can actually be very depending on our workloads, depending on our product application needs, build the schedulers to fit things very well. Right. Netflix had a very good example. They presented their scheduler called Fenzo. It's not open source yet, but they were planning to, which was doing distributed stream processing, but they were integrating that inside. They were basically making the streams local as much as possible. So if you have 5 things that consume the same streaming data, that's different, because if you aren't really doing stream processing properly. So they should really just be consuming from the same spout and have all of those nodes be scheduled on the same box if possible, right?
Yeah.
So you can, those things, like if you start building that, then you can't really do that with a completely fair scheduler, right? And you get to like have both worlds in this case, and Mesos actually allows you to run like two frameworks. Actually, I can show you this quickly too. The way Kronos is running was I'm running it as a separate process from the master and registering it as a parallel framework, as opposed to having Marathon dictate that. It's arguable if it's a good idea or not, but it's working so far. So
Yeah.
I may stop doing that at some point.
And how do you see like the management of this scaling? Like I'm trying to envision like when you have a team of developers, what is their interface into this, right? Are they going to be looking at it at the Mesos level, or are they doing it at the Marathon level, or some other level, right? Because then we start getting into like running a platform as a service on top of some of this.
I see developers only really interacting on the container level, right? Where you build a container, you give you give a service to your end consumers, right? That's where the most value is, right? What Mesos should enable is you to be able to throw it over the wall, say, make this go, spin me 5 instances because that makes sense, and you should be able to give hints. I would really like this to be on 2 different availability zones because I have a big launch coming up, and I really want it to be at least on these at all times, right? And you're keeping like 5 regions lit up at all times. So you may not need that at all times. So the developers need to be aware of what the requirements are. It also unburdens. There's no reason we wouldn't expose, say, what the logs are, what is Mesos doing. I don't really expect everyone to be doing all the same things all at the same time, but for operations, it removes the sort of ongoing battle on, okay, do we use Chef, do we use Puppet, do we use whatever. It's like, well, just spin a box, make sure it's registered with Mesos, make sure it's registered with Zookeeper, and let people deploy Docker containers and we're good to go, right?
And so, do I understand correctly? You're saying that Mesos, you can actually have one infrastructure that's actually spanning multiple like EC2 availability zones.
I've seen people do that. We still need to be very, very aware of that. There are people. It's another layer of automation, right? Where the way I see it is, you could have multiple Mesos instances in different regions. There was a very good demo by John Wilkes from Google at MesosCon, which was what they did was ran a cluster, Mesos cluster at Mountain View, ran I think another one at US East one of Google Compute, and live they shut down the whole cluster. So a meteorite strikes, and they were able to fail over entirely to the new one, right? And the way I see it now is like there's a convergence where it's possible on a single region now. We just need to tool and understand how it can be done on multiple regions that way. Yeah.
I see. So the foundation is there, but maybe the execution, or are there actual pieces missing, or do you think it's hard to get all the pieces set up correctly to do multi-region?
I think the pieces need to be set up correctly. There's as soon as you look at cross-region failovers, you make problems like DNS recovery. You have your service, like maybe you have HA proxy pointed to, whatever TCP endpoints. How are you going to fail over that? Maybe you're running WebSockets. How are you going to move those things? So those become much more apparent, and I don't really see really a way around making, having the product owners really look at, okay, this is, this is how much we can, like, if catastrophic things happen, we can, we can move. But for anyone who's like deploying something, it should be just as easy. Take the same Docker container and put it somewhere else. The nice thing is we know how to replicate databases. We can run things like Cassandra across multiple regions. So a lot of those pieces, I think the hard computer sciencey parts are there.
Yeah.
Just need the people to catch up.
Yeah, exactly. So I get it. It's more about making sure that you have an architecture for your application, and when I say application, I mean all of the moving parts that make up a large, web scale, not web scale. I actually meant to say website of a large scale. So I know that's a buzzword, and it just kind of came out. A large website that's got a really big scale. You need to actually architect it in a way that it's already has the ability to run in multiple regions. This layer of it will make it easier, but it doesn't it doesn't make anything magical.
Yeah. There's a really cool project that I would like to plug. I started. I was going to demo that, and then I couldn't get their Vagrant images to work. HubSpot guys have a project called Singularity, which they use to deploy. It's all open source. Deploy Java services, Marathon, Chronos, like basically one system to rule them all. So you deploy the system, your drop wizard application, and just run it, right? So those sorts of things. So that is very interesting stuff to watch, right? Which would lead to being able to deploy to multiple regions, fail over nicely, and so on and so forth.
Very cool. So we have about 3 minutes left. Is there anything else you kind of wanted to cover before we wrap up?
Brian Demers, did you have any questions?
Yeah, so I've been kind of quiet. I'm just kind of taking it all in. So is this sort of, as it stands, more geared towards like sort of just back-end tasks, like to crunch data, or I see you have web apps too, but it seems to lend itself more towards like crunching data or some task type thing.
Yeah. It's mostly towards like flexible workflows, mostly aimed towards like back-end stuff. Things like Marathon really make it possible, or made it possible to run websites, all those sorts of things. I haven't run it for like long enough of time to, or at load where what kind of performance either or looks like, but really aiming at both of those use cases and think of the problems from, I have a data feed, I have a stream coming in from this side, I want to expose that on an app. I want them to be as close as possible to each other without necessarily going in and looking at the hardware or looking at all of these things, and sometimes not have that, right? If the product requirements doesn't justify or need that kind of latency support, stuff like that, be able to do that. So I think it's both, mostly aiming at what the community already is doing and building up on it.
Cool. Well, any other questions, Brian?
No, I just run out of time. But what about like so from the web app front? I mean, if we're spanning sort of different cloud providers, this gets a little trickier. But is there anything sort of built in to do like auto scaling or anything?
So, with Marathon, I think we still have to write something. So like one thing I was thinking was, so your health checks could really just be Chronos tasks. that are running all the time, and then looks at, okay, what is the load on this right now? And then if it's more than this metric, or then Kronos itself, like during the task run, just scales you up or scales you down. So what I find attractive about this is like your whole system really just ends up being like actually working on the same computer in many ways, where like I just watch a process over there, and that bounces things, and like I don't really worry about how exactly the kernel is doing any of its like hard work. There isn't anything specifically that I mean there are people who have written stuff like that. Twitter runs a lot of their stuff. They're getting very, very close to critical systems at this point. On Mesos, Airbnb runs a lot of their stuff too, so it's doable.
Cool.
Very cool. Well, great. Well, we've run out of time, but this was really enlightening. I really like this space, and I'm seeing it in action. I'm starting to really get where Mesos and Marathon and Kronos all fit in, which is basically to create an abstraction layer that feels like a local computer across cloud providers. So
it's helping the operations too, right? As opposed to just adding one more layer of abstraction.
Yeah, exactly. So developers benefit, operations benefit, kind of everybody in between. So awesome. Well, thanks for your time, guys. Pleasure as always, and I'm looking forward to kicking this series back up again, and we'll do this more regularly.
Yeah, that's good.
Bye.
Bye, guys.